So we'll get started here. A couple things, just kind of housekeeping stuff to get out of the way before you jump into material here. I will get those module 1 and 2 readings kind of updated. I know there was the ones that haven't been graded, like the free and open response ones, just get credit for kind of responding. I know I've got some emails I haven't gotten back to over this past weekend, so I'm not going to always necessarily be able to get you responses right away, although some of you reached out and I was able to kind of get some quick responses out. I'll kind of be doing those this afternoon. So if you've emailed me and you haven't heard back from me, you'll hear back from me this afternoon. I just have to kind of get through all those that I received over the weekend. I also have like half a dozen of you. Does anybody have issues with the select all that apply on the Canvas quiz? So I'm seeing a handful. Okay, so I reached out to the tech people. Don't worry, I'll end up giving everyone credit for those questions. I think it was 2, 3, and 12 or 11. I forget exactly the numbers. I'll have to go in and do that this afternoon as well. They told me that they can't figure out anything why it wouldn't work on their end. Their only suggestions were to clear your cache and cookies, right? Like that option, you can go through settings in whatever browser you're using. They also mentioned that the browsers that they have the least issues with in terms of Canvas and these, you guys don't care, but it's like a new quiz feed, like they're redoing their whole quiz interface. So they said the two that have the least amount of problems are actually Firefox and Microsoft Edge. So I'm guessing a lot of you are probably using Chrome or Safari. So that could have been causing some of the problem with this new kind of format of multiple answer questions. So you know, I think an easy workaround, it's pretty easy to download Firefox and then kind of use that if you were using Safari or Chrome before. And then hopefully moving forward, first of all, there won't be as many of these kind of multiple answer questions anyways. But hopefully moving forward, that should settle it. So clearing that cache and cookies through your settings on your browser or using one of those other two browsers, hopefully should kind of fix that moving forward. I'll still be talking with them, trying to really, and I've asked those of you that emailed me, I asked you what browser and stuff you were using. So I'm going to try to find a consistent theme as to which ones were having problems and try to get an answer or solution to that before we have any other, before this next week's quiz. But I will get those scores updated, so that isn't going to cost any of you that had that issue. I'll give everybody credit for those questions. Someone also reached out, kind of mentioned, I did mention this last week, but the packback assignments. So if you go to the actual platform, you might see like that they exist, but you can't access them. So those are kind of set to release like as we get through the material that those packback assignments will cover. The first one will be posted after class Thursday. So I'll talk a little bit more about that on Thursday. Going to show you the interface, show you the actual assignment, have it set to release so you can all see it. But I kind of do that periodically and I don't release them until after we cover the material that assignment, packback assignment is specific to. Okay. We will be using in-class top hat quizzes this week. In fact, we'll kind of do the first one today. As I cover material, I'll ask you a similar question just to kind of so you can put it into practice. I think it's just gets you used to seeing how different material will be put into question form, right? So half of those are for correct, or half of it's just for being here and responding. The other half is for getting them correct. And a lot of the times I mentioned last week, I'm pretty nice and maybe give you some strong hints. I should be able to, if I don't get to it today, for sure tomorrow, post the CL session list. In practice though, this week you can plan on, go to whatever session works best for you. They're, at least in my experience, they have never been full. I'm just kind of creating a list just in case they ever do get full. You do have a reserved time and space or in one of those. But in practicality this week, whichever one you want to attend, there should be open seats. So those start this Thursday. Okay, and I'll mention this again after Thursday's class. And I think that should cover the stuff that kind of want to get into before we dive into material. Any questions for me before we get going here today? Okay. All right. So let's start off. We're going through module 2 here today. So we're going to set up, this is kind of a, I don't know, really easy example initially, and then we'll kind of see how we can maybe complicate this. But let's say I just had 2 goods that I can produce in an economy. Computers and produce, right? Like, so some type of, corn, wheat, whatever you want to think about. We're creating technology goods and we're creating kind of sustainable agricultural goods. Okay. If I've got one resource, and we can complicate this by adding more, but for the sake of this class, we'll stick with just having one resource. And here it's going to be 50,000 labor hours, right? So in my economy, I've got people living, right, and working, and I can take their work, their labor hours and put it towards either producing computers or producing some type of agricultural product. So I think I said, yeah, I chose wheat here as the agricultural product. So, it takes a lot more to get a computer than it does to get wheat. And so for every computer we want to produce, we're going to need 100 labor hours. Well, if we only had 10 labor hours, that's going to get us a ton of wheat, 1 ton, right? So you can kind of go through, okay, well, if I had 100 labor hours, right? I had what, 50,000, right? If I put them all towards computers, I could get what, 50, oops, there we go. 50 computers, right? Just kind of dividing the number of labor hours by how many hours it took to get one computer. So 50,000 divided by 100. If I put all my resources towards computer production, I can produce 500. Okay. And then you kind of think about, as I start to transition some of those labor hours. So let's say now I only put 40,000 of them towards computer production. Well, each computer costs me 100. So once again, divide that by 100, I'd get 400 computers. And then I now have kind of 10,000 labor hours going towards wheat production. Well, every 10 hours gets me a ton of wheat. So I divide this by 10 and I get 1,000 tons of wheat. And then I can kind of continue to go through and do this for every different allocation of my labor hours to these 2 different goods. And economies do this, right? I mean, it's not 2 goods, right? It's a much larger set of goods that we start to put kind of our labor hours towards. And some countries put more towards others, right? The US probably puts more labor hours towards technology, producing probably not even actually physical goods, but almost like, intellectual kind of property. Whereas countries that are not as economically developed are probably producing things that, we trade with them for. So this might be things even like agricultural products, right? Or this might be things like, we don't want to waste our resources producing, little plastic things that are sold at Five Below, right? We're probably getting a lot of that production from overseas, right? From countries that aren't as economically developed yet. So here we've just simplified it to 2 goods, 1 resource, labor hours, and here's kind of the different I chose 5. In theory, you could choose, I put 49,999 labor hours towards computers and 1 towards wheat, and then 4,998 and 2. I can make this as delineated as I want it to be. Just for the sake of this example, we're just going to think about 5, different allocations of these labor hours. Okay. So what we're then going to do is take these points, and create what we call EPC. Let me see if I can get this on here real quick. There we go. Maybe. All right. So we're thinking about this allocation of resources. And I think I have this. Hopefully it'll match up with the slides. So we can give a graphical or a visual representation of this, because it's just different combinations. Let's see if I plotted every single one of those points that I just showed you, we could create this different possible combinations of these 2 goods that my economy could afford to produce given its labor hours. So the very first one, we said what? If I put all my labor hours towards computers, if we go back to the slides, 500 computers, and then I'm putting nothing towards wheat, so I get 0 tons of wheat. And if I was only producing wheat, I think we had what? 5,000. And then if I'm putting all my resources towards wheat, I have 0 computers. But then we have these points in between. So this was, so we go 400. And then what was this? 1,000, right? And then I think this was the second point. And I'll try my best to draw this to scale, but it may not be perfect. And then the other point we had was 100. 4,000, right? So I said before, I can make this as, I could do this by 1 labor hour transitions all the way down. And I kind of get this, what we call our production possibilities curve, okay? Now, this is supposed to be a straight line. I'm just not great at drawing all the time, right? So this is supposed to be a straight line here. We kind of have this relationship between, as I'm trading off the labor hours that I'm putting towards computers and then putting them towards wheat, I'm getting fewer computers, but I'm getting more wheat, right? We're going to talk about what that trade-off is here in a second. But this would be my production possibilities curve, okay? So I'll jump the gun a little bit and think about, okay, if I look at this line, right, it's going to have, every line has a slope, right? So how do you generally calculate a slope? rise over run, right? Or a change in y over the change in x, right? Y is your rise, x is your run, however you learned it, right? So I can think about here, if I just take my two extreme points, it's very easy to find the slope of this line, right? Because if I'm going from 500 to 0, right? And then 0 to 5,000, I get negative 1/10, right? Now notice, this is always going to be negative, right? The slope of this curve is always going to be negative because as I'm producing more of the other, of one good, I have to produce less of the other, right? I've still got that same bank of 50,000 labor hours, right? So as I start to put some of them towards wheat production, I automatically have to see a reduction in the quantity of computers I can produce. So this slope of our production possibilities curve is actually going to be the opportunity cost of, producing one more unit of wheat or ton of wheat in this example, right? So for every additional ton of wheat I want to produce, it's going to cost me 1/10 of a computer. So the slope of this production possibilities curve essentially represents the opportunity cost of our x-axis good, right? So to get one more unit of our x-axis good, if we calculate the slope of this production possibility curve, it tells us what that trade-off is or what the cost is in terms of the other good. Here, one more ton of wheat costs us 1/10 of a computer. Okay? And this will always be the case when we're looking at these production possibilities curves. The slope tells us the cost of producing one more of the x-axis good. I'm saying this a lot, but this is because we're going to use this a lot. Okay. Now, hopefully, you kind of see, I mentioned, this idea of like the final even being not really cumulative, but it is in the sense that everything builds. We're already building on stuff we learned from last week. I'm mentioning opportunity costs, right? So we have to have some base reference of that terminology this week for me to start saying things like the opportunity cost of one more unit of wheat is 1/10 of the computer, okay? So this production possibilities curve just represents this trade-off, right? Any questions on this before we keep moving? Shouldn't be too bad. All right, so where at? Yeah. Yeah, so in general, if you're asked for what the cost is, it's kind of already implied that it's negative. So when we calculate these costs, we wouldn't say it's like negative 1/10 it's just 1/10 of a computer, right? That is my cost. It's almost, when I say the word cost, it's inherent that it's going to be negative. But just the pure mathematics, when you're calculating that slope, you will always end up with a negative value. Yep. And when I'm asking you for what that cost is in terms of the other good, you don't have to put a negative sign. And I won't ever try to trick you by putting like a negative sign. Like if I gave you multiple choice, they would all be positive. Sorry, any other questions that I missed a hand? Okay. Oh, I got these back up. So once again, kind of like last week I mentioned, sometimes I'll leave these slides blank, right? Then I'm going to do some work up on the .cam for it, okay? So it's a good way for you to know how much work is going to be maybe done in class. Also a way for me to remind myself that I wanted to draw something for you. So I kind of already mentioned this, right? And we looked at it already, but the cost of that x-axis good is going to be the slope, right? Now, to your point, our slope is always negative. In general, we just, because we're saying it's a cost, we kind of ignore that negative sign, right? It costs us 1/10 of a computer. Yeah, technically you could think about it as I'm giving up 1/10 of a computer, so it is negative 1/10, right? Now to get the slope of, to get the cost of my y-axis good, I could actually just redraw it if I wanted to, flip which good I put on which axis, and then I find the slope, I could figure out the cost of the other good. What ends up always being true, this is kind of nice rule of mathematics, if I were to do that, I would always find that the slope of that y-axis good, if I were to switch them, it'll always be 1 over the slope of what I originally had. So if I go back to, come on. Okay. Why is it not like this? Give me 1 second here. Well, it's not letting me switch. It's not letting me switch this. All right. We're going to reset it. Oh, now it's trying to do things. Here we go. There we go. All right. I don't know what it's dealing with, but I think it's got lag. So we already talked about the cost of that 1x unit of the x-axis good was our slope. The cost of one more of our y-axis good would always be 1 over that slope. Okay. Now it gets a little bit tricky when we're dealing with fractions. If you have a basic calculator in front of you, though, if we do this math, this just ends up to be 10. Right? So for every 1 computer we want, we have to give up 10 tons of wheat. Okay? So all you have to do is take 1 over the slope of your x-axis good, and that gives you the cost of your y-axis good, or in this case, the cost of 1 computer. Okay? Now you can kind of think about this, this kind of makes sense because the whole setup of this was, it took 100 labor hours to get 1 computer. It took 10 labor hours to get 1 ton of wheat. So if I want 1 more computer, how much wheat do I have to give up producing? Well, it takes 100 labor hours. Every 10 labor hours gives me 1 ton of wheat. 100 divided by 10, I have to give up 10 tons of wheat. So if you can think of it intuitively, then you don't have to like draw it out and do the math. For me, even, I can think about it in my head, but it always makes it a little bit easier to draw stuff out, right? So that's going to be a lot of stuff in this class. You can intuitively think about it, but the deeper into the semester we get, there's going to be things that your initial instinct in like your intuitive brain may not do as well as if you actually draw out the graph associated with it, and it can prevent you from making some really easy mistakes, right? If you're drawing things out. So here, slope will always give you the cost of 1 more of your x-axis good. 1 over the slope will always give you the cost of your y-axis good. Okay, always. So let's see if we can transition now here. It goes crazy on me again. All right, there we go. So it closed out my slides for some reason, so we'll open those back up, and we were right here. That's okay. It's not what I wanted. I want a slideshow. There we go. So if we have our example, we calculated the slope of our line, the cost of that x-axis good, which was wheat, was 1/10 of computer. And then the cost of our y-axis good was 1 over 1/10, or that slope of 10. Right? So you could actually, like I said, if you wanted to rework this and just switch the goods, in which case you would have found the slope is -10. And then if you had computers on that x-axis, that was the cost of 1 more computer. You could then do 1 over the slope to get the cost of wheat, which we now have in the y. Like you can always, it doesn't matter which good you put in which axis, you can always find these slopes, okay? And these costs. Any questions on this before we keep moving here? Should look somewhat familiar with some of the stuff that was talked about. So I'll give you kind of another example. Let's say, I don't know, the CEO of Ford. I don't know who this is right now. I'm a Lions fan. I know that Sheila Ford is still somewhat involved, but she's not the CEO. She's just the owner. So we have the CEO of some major company. Here I'm choosing Ford for a reason. So I'm thinking about this person's really good with cars. They can fix their car. This has some issue. They can fix it in an hour, right? If they took it to the mechanic can do it in 3 hours and is going to charge the CEO, what, $200. So why might the CEO not choose to fix their own car? Yeah.
This time for more than 200 an hour.
Yeah, right. Even though it's going to take the mechanic a longer time, right? The CEO's time is very, very valuable. Someone asked me, maybe not from this section, asked me a question last week or stopped by my office. And I tried to look this up, and I think it was Mark Cuban that they were talking to who said this. They asked him about why he doesn't fly commercial and why he bought like his own private jet. And he was like, the amount of time that I lose waiting for commercial flights actually makes monetarily more sense for me to buy my own jet because it's costing me so much money, right? My time is so valuable that this time I'm spending in airports, it actually makes financially more sense to buy my own plane. So this is the same idea, right? So we kind of think about the CEO, if their time is valued at $2,500 an hour, well, then by taking it, fixing it on their own, even though they're doing it an hour, that's costing them $2,500 as opposed to handing it off to a mechanic who can do it for $200. Okay? So, we're thinking about here, the resource we were thinking about before was like labor hours in an economy. We can think about also like, what are your personal resources? A lot of times it's your time, right? And here is kind of a nice idea to see kind of different valuations in time, right? So this kind of leads us into, we'll analyze a very basic model where we have two individuals and then two goods. This could be complicated if we wanted to kind of take it to 500 goods and 1,000 individuals in the economy. The math just gets harder, right? But we're just going to stick at the basic core of this, which is absolute and comparative advantages for two individuals who are producing two different goods. Okay. So the definition of absolute advantage, you've read the kind of module readings, maybe you kind of retain some of this, but it's just that using all of my resources, can I produce more than the other person, right? Or can I produce the most? And we only have two people in our example, so it's kind of easy, right? So in our example, the CEO had the absolute advantage. He could fix that car quicker. He only had to spend 1 hour as opposed to spending 3, right? So if we only had the CEO fixing cars, we could get more cars fixed in a day than if we relied on the mechanic. A comparative advantage, however, is can I produce something at a lower cost? Right? And so if the mechanic and the CEO's times are valued differently, maybe giving up 1 hour from the CEO, that's actually a much higher cost than the mechanic giving up 3 hours. So comparative advantage, and you could think about this, it's individuals, firms, countries, whatever. We can do several different types of examples here. Whoever can produce a good the cheapest or at the lowest cost, we say they have a comparative advantage. Okay. So in our example, we probably think about the mechanic has a comparative advantage. Their time isn't near as valuable as the CEO's. Right? I didn't actually tell you how much their time was, but let's assume it's, I don't know, even if it's $100 an hour, way below that $2,500 for the CEO. Right? So we'll do a country example here because I think we can maybe make the connection to like some more real world stuff. So let's say I got what? India, the United States, and I'm thinking about iPhone, aircraft production. If they both devote all of their resources towards producing one of these two different types of goods, that's the information that we'll generally start out with, and then we'll kind of go from there. So we'll represent this a lot of the times, these examples we'll work through in like kind of this little small matrix, right? Where I've got both countries, both types of goods, right? And these numbers represent that if the United States is putting all of their resources towards iPhone production, they can produce 60. If they put all of their resources towards aircraft production, they can produce 30. So this is kind of like either or. It's not at the same time. It's all of their resources towards this one good. Same thing for India. So if I look here, who has the absolute advantage in iPhone production? US, right? If they put all of their resources, they can produce 60 as opposed to 50. What about aircraft part production? The US. So you can have examples, right, where countries, individuals, firms have an absolute advantage in the production of both goods. In practice, like there's, the United States has the absolute advantage in the production of a lot of different goods, right? It doesn't just have to be one good. It can be both of them, right? Or all of them, right? Not to get too inflated. We probably don't have absolute advantage in production of everything, but a large number of things, right? So what we can then do is think about, okay, how do I determine who has a comparative advantage? Okay. So actually, I think I've got this in a slide, but I think we'll have time. I can draw this out for us. So what we'll do to determine these, look at that shadow there. If I think about, and now let me see here. Need to see the numbers. Okay. So what makes the most sense? Let's do iPhones and kind of aircraft parts down here. Okay. If I'm drawing out the United States, you get what? 60, if we're putting all of our resources towards iPhone production, and then 30 aircraft parts. So I kind of draw a line in between the two. I can think about this is like the US's production possibility curve. Okay. So what's the cost of an aircraft part to them? Right? So if I think about what's the cost of one aircraft part to the US, well, it's just going to be the slope, right? So we said the cost of the x-axis good is just the slope. So here, what's my change in y over change in x, or rise over run between these 2 points? 60 over 30, or for every aircraft part, we're giving up producing 2 iPhones. These numbers probably don't make sense, but there's some easy numbers that kind of give us a nice example here. Okay? Then I could say, okay, what about India? All right. So India had, I believe, 50, and then try to draw this kind of to scale. 10. So the cost here we have India is kind of PPC. So the cost of one aircraft part to India is going to be what? 50 over 10, or 5 iPhones, right? And you kind of can see this just with these basic numbers. Like India was a lot more productive when they produce a lot more iPhones than they can aircraft parts, right? That ratio is a little bit closer when we're looking at the US. So here, the cost of an aircraft part is going to be much higher to India. So whoever has the lowest cost is who we said has a comparative advantage. If you draw these PPCs, we can clearly see like at both of these extremes. So like you can think of it as like the X and Y axis always tells you about the absolute advantage, right? The slope is going to tell you the comparative advantage. So whoever has a steeper slope, that's a higher cost, they don't have the comparative advantage. Whoever has the flatter slope is going to have the lower cost. So here we would say that the US has a comparative advantage in aircraft part production. Okay? Any questions on that before I keep moving? I'm going to do something that's a little bit more tricky here. Yep. Yep. Right. The steeper our slope is getting, the larger that technically these are all negative. But we're talking about in terms of cost. So it's going to be getting steeper and steeper. That slope is going to be becoming a larger and larger negative value. Your cost is getting higher and higher. Yep. Any other questions for you? Okay. So it's the law of mathematics, and we won't work through the mathematical proof. But anytime if, like, for example, 5 is greater than 2, if I wanted to find the cost of the y-axis good, what would it be for the US? 1 over the slope, right? So if I want the cost of my y-axis good for the US, it's going to be 1 over 2. Or for every iPhone, I have to give up half of an aircraft part. What about for India? Well, there it's going to be 1 over, I'm trying to color coordinate these so I don't have to write the country's names every single time. If you're taking notes and you want to kind of write the country name next to it, that might be helpful when you go back to look at it later on. So here they would have what? For every iPhone they produce, they're only giving up 1/5 of an aircraft part. Well, 1/5 is smaller than 1/2. So notice we end up with India has the comparative advantage in the production of iPhones, or the y-axis good here. So you can only ever have a comparative advantage in the production of one good in these 2 good models, because anytime you have a higher cost, if I take the inverse of numbers, so like 1 over 5 and 1 over 2, that's taking the inverse, and you don't have to worry about this. But just the law of mathematics, this is always going to flip that sign, right? Anytime I take 1 over something, inherently, it has to be that my fraction is now the one that had a larger number. When I take, put that in the denominator, that's now going to be a smaller value. So I think by rule of thumb, the easiest way to do this, find who has a comparative advantage in the cost, in the x-axis good by finding the costs of the x-axis good. It's easy to find the slope. And you don't have to work out all this math every single time. Once I know that the US has a comparative advantage in aircraft part production, I automatically know India has a comparative advantage in the production of the other good, or in this case, iPhones. Right? It'll always be the case that you only have a comparative advantage in the production of one of those goods. Okay? Any other questions on that? And like I said, the math gets more complicated once we start throwing more goods in there. We're sticking at kind of two people, 2 country, 2 good models here. Okay. Any other questions? Yeah. Yeah, right. This only works like what I'm saying only works out to you 2 and 2. It would be a little, the math is more complicated, but yeah, if I have 3 goods, it could be that I have comparative advantage in production of 2 of the 3, but it would never be all 3, right? There will be one good in which the other person would have to have a comparative advantage. All right. Any other questions before we keep moving here? Okay. So, oops. All right. I drew this out for you, so I've got it in the slides. I think I just flipped the goods in this example. So I wanted to make this point, like it doesn't matter which way you start, right? So if I had this information and instead of putting aircraft parts on the x-axis, I put iPhones, well, I could still figure out who has the comparative advantage, right? Because I could do the slope here of each country's production possibilities curve. I think if I do this here, so I've got 0.5, right? 30 over 60 was the cost of an iPhone, the x-axis good for the US. 10 over 50 would have been the cost of that x-axis good iPhones for India, so 0.2. So even if I had started out and I accidentally flipped those goods, I can still figure out India has the comparative advantage in iPhone production. They have a lower cost of the production of that x-axis good, which inherently means that the US has to have a comparative advantage in the other good, the y-axis good of aircraft parts. Okay, so it doesn't matter which good you put on the x or y-axis. You know, the math will look a little bit different, but you can still determine who has a comparative advantage in the production of both goods. Does that make sense? Any questions on what I just said? Right. And you don't have to work out both of them every single time. You know, you only have to really choose one, but I'm just making the point here, doesn't matter which way we would have chosen, we could have gotten to the correct answer. Okay. And I move this out of the way so we can actually see my third question. So, you know, who has a comparative advantage? Whoever can produce that x-axis good of iPhones at the lower cost. 0.2 is less than 0.5, so we would choose India. Okay. All right. I think I already went through this as well. I sometimes I kind of go out of where I know I have things in my slides. Sometimes I think it makes a little more sense to kind of go through it all at once, and then I'll just kind of revisit it. So this is a good example of that. You know, once we find the cost of a good, how do I find the cost of the other good? Well, now it's just 1 over the slope. So when I had it set up so that I found the cost of an iPhone, if I want the cost of an aircraft part, it's going to be 1 over the slope for both of these. So the US, it would be 1 over 0.5 or 2 iPhones was the cost of one more aircraft part. I don't know why. I probably changed my countries here. This doesn't make sense. So India, not Brazil. India's cost would be 1 over 0.2, which would give me kind of that cost of 5 iPhones. Once again, now I can easily see here, oh yeah, who has the comparative advantage in aircraft part production? Who can do that at the lower cost? That's going to be the US. So slope, I'm reiterating this a lot. The slope gives you the cost of your x-axis good. 1 over the slope gives you the cost of your y-axis good. Okay, that's just a general kind of generalization you can remember. So at this point, I threw those in there to remind myself. I want to try to do this here today. So generally, this is how I'll do this. I've got the slides like up here. I've got some questions. So I'm going to set it. Let's do the end of class today. All right. So present. Maybe this is how actually we're going to do it this way. Okay. Oh, there we go. So what? The join code today. So if you open Top Hat on your laptop, phone, whatever device you have, log on to your Top Hat. This is probably good practice from here on out. Just get it pulled up, log on at the beginning of class before class started. So whenever we get to the question, there's different days I might start out with questions. Some days I won't do them at the very end. Some days like today, I'm kind of doing it not directly in the middle, but at some point in the middle of class, right? So the join code is going to be 617045 for here today. And then you should be seeing this pop up once you kind of logged on to Top Hat. Is anyone seeing this on their Top Hat account? Yeah? So you should be able to, oh, never mind, I can see, there's 176 of you on there, right? So hopefully you're seeing this, there's 24 of you who have answered. So I won't be able to necessarily display all of the answers. I'll try to kind of scroll down here. But on your device, you should be able to see all those possible answers. So we've got, if I'm using all my resources, how many guns can this economy produce? And I have 4, 6, 8, or 1,400. I know this image is a little small, but hopefully you can kind of see it a little bit bigger on your device. I'll give you guys a little bit of time. Generally, talk to the people around you. I'll give you 30 seconds or so to think about this one. But if you're using all of your resources, how many guns can this economy produce? Don't overthink it. It's not loading. Did you put the join code in? Oh. It's not supposed to do that. Hold on. Let me think how we can speed this up. Well, probably because we're like down low too. Give it a couple seconds. It says error. All right, let's try this. Let's just try to close it out and reopen it. Huh? Yeah, I just closed it out, right? So you guys shouldn't see anything now, right? Okay. No one can see anything now. Yeah. So I just closed it out. So refresh your browsers. Let's see if we can get this to work. This also might be helpful, like doing it at the beginning of class, kind of here on out. I think that'll help us out a little bit too, so everyone's not trying to get in at the same time. I typically don't have this problem even with sections this large, so we'll try this one more time. All right. Oh, there we go. Let's try to get back onto it one more time and see if it's still giving people loading issues. Yeah. Let's give it a minute or two. I'll kind of talk through this one. Whatever. I'll end up giving everybody credit today, so you guys kind of lucked out. But like I said, I think logging out at the beginning of class will kind of help this problem of everyone trying to get out at the same time. And it's still not. It's just taking a long time. All right, I'll have to reach out to Top Hat and see why it's being so slow. So maybe an issue on Top Hat today. Okay, I was gonna say, because I've used it in previous semesters with 300 people, and I generally don't have issues. So it might be. I'm writing notes myself. I'll email Top Hat, and hopefully we'll be able to use this kind of after today. But in general, this is what we'll do. We'll kind of have this open. I'll give you guys 30 seconds to talk with each other, people around you. I'll then say, okay, I'm going to close this question out. I'll then close it. You can no longer get an answer. And after this point, I'll then kind of move to the next question a lot of the times. So, how do I do this? I'll start the second question. What would the opportunity cost be here? So first of all, I think in the previous one, I asked you about, we're using all our resources. How many guns could that economy produce? Yeah, what'd you do? All you have to do is look at those X and Y axis points, right? That tells you that I'm putting all of my resources, none of it towards butter, all of it towards this Y axis good of guns. So the answer would have been 600. What if I wanted the opportunity cost of one more unit of butter? Well, this is kind of nice. Butter's on my X axis. So all I have to do is what? Find the slope, right? What's the slope of this line? 600 over 800 or 0.75, 3/4. I don't know how did I put it in decimal or fraction? Yeah, I put both, right? It's just in case, okay? Yeah. I'll probably just end up giving everybody credit for today's. I have no way of knowing, who had issues and who didn't. So don't worry about the points for this one today. Like I said, I'll email Top Hat, try to figure out what's going on in their end. Moving forward, like I said, it should be a lot more straightforward. It does take a little bit of time occasionally, but usually no more than 5 or 10 seconds to kind of get everybody into the question. And I usually give you some time, 30 seconds to a minute even, sometimes a little bit longer if it's a more complicated problem. So we'll complicate it a little bit. Right now, a lot of the times, we will make this simplifying assumption that we're just looking at two people. Yep. Is everything going to be a what? Not necessarily. Well, yeah, we'll touch on different topics. Right now, we're going to talk a lot about production. Yep. So, okay, I see what your question is. All right. Well, I'll get back to here. So are we okay with kind of finding the cost of this x-axis good? What if I wanted the cost of guns? What would that be? 1 over the slope. So 1 over 0.75 is what? 4/3? Yeah. Okay. So go back to slides. To your question, I think I know what you're asking. So the way that I will phrase the questions for this type of material or this subject in this class, I'm always going to be giving you, if I'm taking all of my resources, how many of this good can that country, person, company produce? I could complicate it more like the first example I showed you. I'm not going to, but where I told you, here's this many hours, right? Or this many of whatever resource to produce these goods. Takes this many to produce an aircraft part, or sorry, yeah, aircraft part, this many of this resource to produce an iPhone. You would have to create these numbers and then you could then find the cost. But no, I'm always going to kind of give you, starting out, a matrix like this, where using all of your resources, right? And in this case, it also allows us to not like have to dive deeper into it, because in practice, we don't really just have labor hours, right? We've got raw materials, we have different types of labor, even we have to like create different categories of labor hours. So what we're doing here is saying, look, there's some crazy production function going on behind the scenes, and we're inputting all these different things: labor hours, entrepreneurship is even one of those you can factor in. How much land we have available, all these different factors of production. You'll be, so there's some function that tells us how many aircraft parts we can produce. We're not worrying about what that function is. We're just saying, whatever all those resources are, if we put all of them towards producing this one good, here's how many I can. Does that answer your question? Okay. Let me think if there's anything else I wanted to say. So, hopefully you can kind of see too, in general, like we work through these like very similar problems, and I ask you like these. I put the picture of the question that I used, or we were trying to use on top hat. And then I ask you like pretty similar questions to what we just covered, right? So I'm never going to ask you a question before we cover the material in class. Okay. So this kind of has a summary of everything that we kind of put together for this example, right? To plot these two countries, figure out the slope, figure out who has the comparative and absolute advantages. Okay. Any questions before we keep moving here? Okay. Where are we at in time? Oh, we're good. It's got 30 minutes. So this kind of sets us up to thinking about. So in my CEO example, right, even though the CEO had an absolute advantage in fixing their own car, they probably are going to want to allow the mechanic to do it. They're going to want to trade, right? Because they know that the mechanic can do something, can fix a car at a lower cost, right? A lower opportunity cost. Now, the other good in that example might be fixing a car and, I don't know, generating revenue for a company, right? And that's why that CEO's time was so valuable. So here we'll kind of keep our example where we're looking at the kind of iPhone production, aircraft part production, and we'll think about gains from trade, okay? So if we think about our example, we said the cost of one aircraft part to India was 5 iPhones, the cost of the US was 2, right? So for India, they're okay paying the US for an aircraft part, any number of iPhones, less than 5. Because if they wanted to produce an aircraft part on their own, they'd have to give up producing 5 iPhones. Whereas if I trade with the US and they say, look, we'll give you an aircraft part and you only have to give us 2 iPhones, well, India's gonna be like, for sure, right? Because if I did it myself, it would be a much higher cost. So you can start to think about, we're willing to trade with the other country in this example, but other person, other company, right? We might trade things as long as they can do it at a lower cost, or they can give us kind of a terms of trade that's below our own cost, right? So we think about the US, how many iPhones would they be willing to kind of accept, right? How much, like, what would their price be? So when India, we know, would be willing to trade for an aircraft part for anything less than 5. But that doesn't mean the US is necessarily going to want to give that to them, right? The US, if they produce an aircraft part, how many iPhones were they giving up producing? 2. So if they're going to give away an aircraft part, they want to make sure they get more than 2 iPhones back. So we can think about the terms of trade here is going to be anything in between. And we don't, once again, the equality, we're going to leave that off, because there we would say that the country is indifferent, right? If the US gives up an aircraft part to India and they get 2 iPhones back, well, they could have produced it themselves and given up 2 iPhones. They don't care either way. They have the same amount of goods at the end of the day, right? So that's why we kind of have this strict inequality. It's not greater than or equal to. It's that the terms of trade, the cost of an aircraft part that these 2 countries agree on, has to be somewhere in between both of their own costs, okay? So then what if I was thinking about what would the terms of trade here have to be for an iPhone? In between what values? 1/5 and 1/2, right? We would have to find the cost of the other good. We did that earlier by 1 over the slope, right? So 1/2 and 1/5 of an aircraft part was how much each country had to give up to produce 1 iPhone. So the terms of trade for 1 iPhone has to be somewhere in that range, right? It's somewhere in between 1/5 and 1/2, which is, I think, what I have right here. Just rephrasing all the questions, kind of revisiting what those costs were, right? And the same kind of logic applies. If it was going to cost the US half an aircraft part to produce an iPhone, well, then they're willing to give up anything less than half of an aircraft part when they trade for 1 iPhone. And then India, well, it was going to cost them 1/5 or 0.2 of an aircraft part. So when they're trading away that iPhone, they want to make sure they're getting back more than 0.2. Because if they're not, they could have just produced it themselves and it would be at a lower cost. So our terms of trade is going to be anywhere in between the 2 different countries in this example, or companies or individuals' costs. Okay. Questions on this idea? I went a little bit quicker through this second part of it. Okay. All right. So, if we look at these opportunity costs, right? If we walk through the logic, what do we notice? Oh, it's always going to be that terms of trade is going to be in between those 2 countries' costs. Okay. And once we find one terms of trade, it's very easy to just do 1 over those numbers and find the terms of trade for the other good as well. Okay. Now, the social aspect of this agreeing to trade, and obviously trade is much more complicated in the real world in terms of coming to agreements with other countries about what you're doing. But this is the general kind of simplified idea that if we were able to, all factors set aside, just say, okay, if we're both at the bargaining table, what's a number we can both agree on? It's going to be somewhere in this range. Now, obviously, every country wants it to be a little bit, so here, if I'm thinking about India, they want that terms of trade to be a little bit further away from 5, right? They want to be giving up as few iPhones as possible. And the US, obviously, well, they'd like to get back as many iPhones as possible for that 1 aircraft part. So they'd like it to be a little closer to 5. So where we end up in that range is not, well, we're trying to touch on this a little bit in module 12, I think. One of the modules where we talk about game theory. But this is more of like bargaining, right? Which we're kind of diving into that topic right now. But we do know that it will fall somewhere in this range, right? Exactly where, it's a little bit more complicated. We're going to need a little bit more kind of a larger skill set to kind of answer that question. But for now, we're just focused on what is the range of possible values where trade could occur, okay? All right, so just to kind of prove why this trade would then be beneficial to both, I'll walk through like an easy toy number example so we can see that, okay, we can come to an agreement, but why would we do that? Well, hopefully we're doing it because at the end of the day, once we're done trading, we're both better off. You're producing something that you're better at producing, that you have a comparative advantage in, and I'm producing something that I'm better at producing, the one I have a comparative advantage in. So here, let's assume that we start out no trade, and India, is producing 25 iPhones. And if we did the math, right? So we had these, scroll back here so I don't have to fly through all these. So we have these production possibilities curve. Let's say we chose 2 points on each one for both of these countries. So The ones that I'm going to choose are that India is producing 25 iPhones, which means that they only had enough resources to produce 5 aircraft parts. And then the US, if they produce 15 iPhones, they could produce 22 and a half aircraft parts, right? Those were 2 points on those production possibilities curves. Okay? If I want to think about trade, well, what could we do? Right? Let's say that these countries, we had that terms of trade for aircraft part was somewhere between 2 and 5. Let's just say they agree on 3, right? They both agree that when we're trading, if one of us gives each other an aircraft part, the other would give the other country 3 iPhones. We've agreed on that. So if the US says, okay, I'll give you 5 aircraft parts, and this terms of trade means that then India, to get those 3, would give up, to give those 5, would give up 3 for each one, so they would give a total of 15 iPhones back to the US, right? And then if we think about now, how many aircraft parts does the US have? Well, I forgot to say something. Here's the original scenario where there was no trade. When we're trading, we're going to have both countries only producing one good, right? So we're going to rely on each country. Once we know that there's a terms of trade we both have agreed on, I'm only going to produce what I'm the best at producing. You're only going to produce the best at what you're best at producing. So the US is producing only aircraft parts. That's what they have the lower cost in. Right? And India is only producing the iPhones. Okay? So when the US was only producing aircraft parts, they could produce 30. They're now trading 5 away. They're giving 5 of them to India. And in return, they're getting 15 iPhones. Right? So we can kind of think about for the US, they are now having 25 aircraft parts and 15 iPhones, which you can kind of see it's a little bit better than they were before. Not a lot better, but a little bit. Right? And then India, if they were using all their resources to produce iPhones, if we go back to that graph, I believe they could produce 50, right? So they're now giving up 15 iPhones in order to get 5 aircraft parts. So 50 minus 15, they're now left with 35 iPhones and 5 aircraft parts, which, yeah, they have the same number of aircraft parts, but they have more iPhones, they're better off, right? And the US has the same number of iPhones, a few more aircraft parts, they're better off as well. Now, once again, an easy toy example, 2 countries, 2 good model, but the same would apply. The math just gets harder if we kind of start to add in more countries and add in more goods, right? But here we're going to see, if we start to rely on people that can produce something at the lowest cost, both people are going to be better off, or both countries in this example are going to be better off, okay? And here's the math that kind of backs us up, right? And you could choose different numbers. Maybe the US wants to trade away, I don't know, 10 aircraft parts, and you can kind of work through the math and just see like there's more goods in the entire world when we have this trade going on, and now people are only producing what they can produce at the lowest cost. And I think intuitively that makes sense. If people are producing something at a really high cost, that's like wasting the world's resources. We should be relying on who produce things at the lowest cost. Okay? Any questions on this before? So we can always find that terms of trade, right? It's going to be whatever's in between the 2 countries' costs of that good. All right. So you don't like free trade. Those are some sweet Nikes you have on, right? A lot of things, probably 90% of the stuff in this room wasn't produced in the US. I'm just going to go out on a limb and guess that, right? So when we have trade, not only is the US better off, but every other country we're trading with is better off as well. And like I said, these are very simple models, but it just extends to more complicated models with just more difficult math. Okay? And I'll use dumb memes like this. I feel like this one doesn't get used anymore. So here we're going to complicate this a little bit more. And in general, I will kind of give you this. I'm not going to make you like build this out for like a 100-person economy, but I just want to give you the idea at least once. And then from there, I'll just kind of show you what I generally will give you as a production possibilities curve. So up to this point, we've kept it very easy, right? 2 good model. We can think about just one resource, and we were only looking at one country. So we had these nice like linear production possibilities curves. In practice, we can think about, let's say, I don't know. Let's think of 2 goods here. I've got agricultural products and then like tech products, right? We've got 2 different types of goods. You don't have to even necessarily choose goods. We can actually think about production possibilities curves could represent like the trade-off between different sets of goods, right? So here, you can think of this as, computers and weed if I want. You can also think about this as like, what are the set of goods that I'm putting my resources towards? All agricultural products. What's the set I'm putting some of my resources towards? Technology products, right? So it can be a little bit more complicated like that as well. So initially, who am I going to want to rely on to start producing agricultural products? People that are really good at it or who can do it at a very low cost, right? So I go to my wife and I go to this is going to make me sound like a crunchy granola person, but we go to the farmer's market on Saturday mornings a lot. And like, there's a lot of like Mennonites, right? They can produce agricultural products at a pretty low cost because in general, like they're not really ingrained into society. They don't have a lot of other job opportunities, right? I mean, if they wanted to leave the community, they probably could, but at that point, they don't. So who do we rely on? They can do it at a pretty low cost, so we're going to start relying on them first. So our production possibilities curve initially, we're choosing the people in our economy who can produce this good, at a very low cost. So remember, a flat curve, that's going to be a very small slope representing a very small cost of that x-axis good. The flatter the curve, smaller the cost. Well, this first person has produced all the agricultural products they can, so what do I have to do next? Rely on the person who would do it at the next lowest cost, right? So their production possibilities curve, their slope is going to be a little bit steeper, right? Because if it wasn't, I would have used them first, right? Because the slope, as it gets steeper, tells me they have a higher cost. The very first person to produce this good will always be, I'll rely on the person who can do it at the lowest cost. So it'll always start out the flattest possible, right? As I rely on people who can do it at a higher and higher cost, my slope is going to be getting steeper and steeper until you get to someone like me. And like, I tried to grow tomatoes this summer and I literally got like a bowl. I don't know what I did wrong. I overwatered them, whatever. I'm not very productive, right? It's a very high cost. It was a waste of my time completely. I got nothing out of it and I gave up doing other things, okay? So this is the idea of our kind of economy-wide production possibilities curve. It's not going to be this nice kind of straight linear line. It's going to have some curvature to it. So in general, we don't break this down like segment by segment. I'll generally just draw, choose two goods, and we'll generally just do something like that, right? This is going to be our economy-wide production possibilities curve, okay? Now, I want to connect this to kind of optimal decision making. So a lot of, you're probably going to be annoyed like with this by the end of the semester, but we started out last week. We said someone will choose to do something as long as the marginal benefit is greater than what? Marginal cost. So here, if I'm thinking about like, we'll go back to my agricultural goods, right? What is the slope representing? The cost, the additional cost of producing one more of whatever this agricultural product I'm looking at is. So I can think of the slope of my production possibilities curve. Let's see if I left myself enough room here. I could directly map that out and say, okay, at this quantity, the cost is whatever my slope is, right? And I could plot that point. It's pretty small, right? It's a really flat slope, so it's a very small cost. But as I produce more and more, what's happening to my costs? They're getting larger and larger. I have these increasing marginal costs, right? And this applies to any good. As I'm producing more and more of something, I have to start relying on people who can do it at a higher and higher cost. Or I'm using less and less efficient resources, if you want to think about it that way. I'm putting this in the context of like people. Those are my resources a lot of times. But it could be like if I want to produce, there's only so much, what's the metal that they need for like high-powered computers? Is it cobalt? No, is that it? Okay, I'm not a tech person at all, but so like we have some products where like I might only have a really small amount of this. If I want to keep on producing, now I have to start making shittier computers basically. So I'm gonna have to rely on something that isn't as efficient as cobalt, right? Or whatever the example is. So here I've got this increasing marginal cost as I'm producing more of something. It's always going to cost me a higher and higher amount, and I'm relying on people who can do it at a higher and higher cost. And then in general, we think about as I'm producing more of something, the very first ton of wheat produced for an economy, well, at least my people can stay alive, right? That's a very, very high marginal benefit. Well, the next couple tons, still pretty high marginal benefit because, I mean, at least now they're not hungry. They can focus on working. They're producing more goods for the economy. Eventually we start getting to the point where what's the real additional benefit? Yeah, we like having more food, but everybody's full. They can't even eat. We've got more food than we need. The marginal benefit is going to be declining. In fact, you could probably argue in the agriculture example, at some point, it probably becomes negative, right? Because now we just have wheat lying around and nobody's eating, it goes bad. Maybe then it makes people sick. Our marginal benefits actually start to be negative. Now, we never get to that point. Why? Because as an economy, we decide where is the optimal production of this agricultural product or wheat. Well, as long as that marginal benefit is greater than that marginal cost, we'll see that good be produced in our economy. So that continues all the way to the point we said where they're equal. Now we're indifferent at that point. That's kind of where we stop.
But isn't it at the bottom where you're using the whole set?
So for sure here, this is where I'm producing the most. Like raw number, I'm producing the most. All my resources are going towards just agricultural or wheat production. At these lower quantities, I'm producing it more efficiently. I'm producing each unit here at a lower cost. Yes, I have more wheat when I get up here, but those last few units of wheat came at a really high cost. So you initially think about it, when I first start producing something, I'm using the most efficient resources possible. Now, I can always continue to produce more and more of it, but at some point, I'm going to have to start relying on pretty inefficient resources, right? People that have no knowledge about how to grow tomatoes in their backyard trying to produce wheat for the economy. Is that?
Yeah.
I understand what you're getting at, though. Yeah. Here, I definitely have more wheat. It's just the wheat that I'm producing here was being very inefficient. I'm the most efficient at the initial point of production. Any other questions for keep moving here? You good? All right. 15 minutes here. Pretty good place. So once again, I think I left this slide open, right? So, we think about relating this, I kind of mentioned this, it's really what we talked about last week in the sense that we're going to have these opportunity costs. And once we think about the economy as a whole, our marginal costs are going to be increasing. We have this kind of curvature to our production possibilities curve, which meant that as I produce more and more of something, this kind of law of increasing marginal costs takes over, right? So we'll see this pop up a lot throughout the semester. As I produce more and more of something, the marginal cost, the additional cost of production are always increasing. We'll have a couple places where occasionally we assume that they're constant, but for the most part, unless told otherwise, we're always assuming that we have these increasing marginal costs. Okay. So I always think about like music or academic things. So initially, if you think about, let's say, it's a dumb example, the economy has a choice between producing some type of academic, or I can put economic papers here, or they can produce songs, music. Well, initially, we're going to rely on who to produce music? My wife would say Taylor Swift, right? And so whoever can do it at a very low cost, right, or is producing that the most high quality music at the lowest cost. And then we have to start relying, on more and more people. If we want more and more songs, eventually you get to people like me, who maybe I can write an economic paper. But if I try to write you a song, it's worthless to the economy, right? So it doesn't matter what goods we're thinking about. We're always going to have to start relying on people who can do it at a higher and higher cost. And if it's easier to think about, not necessarily just a higher and higher cost, but they're just not good at producing it. I can't produce a song, right? So you're taking all of my labor hours and putting it towards something to which you're going to get like no production. So you just gave up anything else I could do with my time and got nothing. It's a very high cost. So increasing marginal costs, we're going to see this pop up a lot throughout the semester. Now the production possibilities curve, although the curve itself, that slope told us the cost, we can also think about it. It really just represents different combinations that we said are going to be efficient, right? So if I go back and think about like this marginal benefit, marginal cost. Every point we would say on this curve, it may not be the optimal point for society, right? That would be whatever quantity we had here. But it is going to be efficient in the sense that we're using all of our resources to produce both of these goods. None of our resources are laying around and going to waste. Okay. I think I'm jumping the gun here, but since I'm already on the dot cam, I think it makes sense. So if I'm thinking about a production possibilities curve, and it doesn't matter what the goods are. So you'll see me do this a lot also. I'm not going to put, sometimes I'll just draw something and just put the quantity of X on my X axis here. Excuse me, quantity of Y on the Y axis. These could be any two goods. We said our production possibilities curve is going to look something like this, right? If I had, millions of people in my economy, technically these are like small kind of lines here, but we can kind of represent it as like a nice continuous function. Okay? So any point on this curve is going to be what we call production efficient, right? We're using all of our resources to produce goods. Nothing's sitting around going to waste. Okay? Anything out here, any point out here is going to be something that, well, think about it. If I'm producing, let's do the easiest example. If I'm using all of my resources to produce good Y here, why can't I get up to this level of production? I'm using all my having resources. So everything out here we would kind of say is unattainable, right? I'd love to be out there, right? I'd love to have more of both of these goods. Why don't I? Because I've used all my resources. Remember, this line represented that I'm using all the resources possible in my economy. Now, how could I maybe get to some of these points? It's something we talked about earlier. Trade, right? But my specific production possibilities curve, I'm limited at the most to be somewhere on it. Now, what if I was producing at a point like down here? Well, this represents that I'm using not all of my resources, right? So we would kind of think about this is we're production inefficient, right? We're not using all of our resources. We got things just laying around, people laying around, not doing anything. We could actually have more of both of these goods if we were using all the resources, right? So we've got inefficient, efficient, and unattainable are kind of our three ranges that we're thinking about with these production possibilities. Yeah. So how do you know where you're going to be? It's going to be a little more complicated than what we'll probably cover in this class. But essentially, you would have to evaluate what the additional, like what the marginal benefits were to each one of these additional units. Like we would have to have some knowledge about, we can get the marginal cost by looking at our production. The marginal benefit is going to be a lot harder because we're going to have to evaluate the benefit that it brings to a person to consume one more unit of whatever good we're looking at. So one more ton of wheat, our economy. That's a lot harder. It's trickier to do. We won't really dive into how we would get those marginal benefits without them being reported to us. So in practice, what we do is probably try to go out and see how much people, what decisions they're making, how much they're willing to pay. And that gives us some idea about their marginal benefit. And then we can like add all those up to get the entire marginal benefit of the economy. And then we could kind of plot that point. But for the sake of what we're doing, just know like you would be kind of given the marginal benefits. You could determine marginal costs from the slope of this, but I'm not going to ask you a problem where you actually have to calculate those values. All you need to know is that the slope of this production possibilities curve, it represents to you the marginal costs, and that those marginal costs are slopes getting steeper, so those marginal costs are increasing. Same kind of thing here, right? When you think about it up here, you've got a pretty flat slope. This means the cost of this x-axis good is relatively low, or I'm operating pretty efficiently, or at least the production of this one good is efficient. Here, the slope is very steep. That means I'm producing these units at a very, very high cost, or I'm using very inefficient kind of resources in my economy. Any other questions? Yeah.
Is it also the most efficient production of the y-axis here? Or is it the least?
Least, right? Because what would the cost of my y-axis could be here? 1 over the slope. 1 over a very small number, so like 1 over 0.1 is going to be 10, right? So it makes right here, I've actually got a pretty high cost to producing my Y good. Those costs, like, because it's always 1 over, they're always like inverse. Whenever my cost to produce is a good question. Anytime I'm producing good X, if I'm doing it at a low cost, inherently that means the current production of my Y good is a pretty high cost. And then as I move down this curve, what's happening? Cost of my X-axis good is getting larger. So now the cost of my Y-axis good, 1 over a larger number, it's getting smaller. It depends on what your economy values, right? That's to the point where it gets kind of tricky. Like, what are the actual marginal benefits to society of consuming both of these goods? And like I said, I think it's module 7. We'll dive a little bit deeper into thinking about things like indifference curves, and we'll model these marginal benefits in a slightly different way. But for right now, probably focus a little bit more on like just the pieces representing your marginal costs. This was more of like to relate it, to kind of show like everything, like this is what we talked about last week, marginal benefits and marginal costs. We choose to do something as long as the marginal benefit is greater than marginal cost. I'm just going to try to tie these ideas together. Yeah.
I had a
No, once again, you won't know exactly where you end up on the production possibilities curve. You would have to be given something about the actual marginal benefits. So we don't know what point we're going to end up on the curve, right? Unless we have more information about what the marginal benefits are. And I'm not going to ask you to kind of do that. We're never going to have to determine. We're never going to have to determine where that where we're at on that production possibilities curve. Hey. We're not done yet, and he's trying to ask a question. Don't be disrespectful, all right? So I haven't given you any numbers to put to marginal benefit. Marginal benefits won't be negative. That doesn't inherently make a lot of sense, right? So we're always going to have some positive value. So yes, there will always be a point. I'm not going to ask you to identify what point is optimal on that production possibilities curve. Okay. All right. So got a couple more minutes here. I try not to be too mean. So I drew this out for you, right? This was going to be the third top hat question. We obviously aren't going to use that. I'll try to troubleshoot that before class on Thursday, but it'll be something like this, right? I kind of just drew this out for you, and then say, okay, which of these points is inefficient? D, right? So they're not going to be crazy difficult questions, right? As long as you're paying attention to material recovery in class, they should be relatively easy, okay? So I'll kind of wrap this up, kind of start on class on Thursday, this idea of production versus allocated efficiency. We'll kind of finish, work through module 2 material. I might have a little bit of time. If I do, I might work through those practice problems. I'll get those up this afternoon as well. Those will be what the CL section leaders work through on Thursday. Other than that, if you have any questions, stop by up here on your way out. I will see you guys on Thursday.